Hello, good afternoon, everybody, and welcome to our Data Bytes webinar on the topic of blockchain in manufacturing. My name is Teresa. I'm going to be your host for the next hour. I work at EIT Manufacturing in Vienna, and together with our expert speaker from ABC Research, who is here with us today, Vinzenz Treytl, we're going to guide you through our interesting topic. And it's, as you can see, blockchain in manufacturing. And most people connect blockchain, this buzzword, with more cryptocurrencies. But I think a blockchain and the related distributed ledger technologies also have a huge potential to disrupt the industrial sector, just thinking about innovative processes or the development of new business models. And more detailed insights on this topic will come now from our speaker, Vinzenz Treytl. Welcome.
Hello.
Vinzenz is a senior researcher and area manager at ABC Research, which is the Austrian Blockchain Center. And his research includes blockchain-based business processes and business models, as well as the economic impact triggered by distributed ledger technology or blockchain. And in addition, he's also a lecturer at the Vienna University, Vienna Institute of Entrepreneurship and Innovation. So welcome, Vinzenz. Can you tell us a little bit about yourself and what we can expect from today's webinar?
Well, thank you for the nice introduction. As Teresa said, my name is Vinzenz. I'm a senior researcher at ABC, more focusing on the business side of blockchain applications. I mean, the natural question kind of what is ABC in the first place? It's the Austrian Blockchain Center. We are a university-owned and government-funded applied research center, which and our mission is to bring forward the topic of blockchain, not only from a financial services perspective, but like from a general economic and technological perspective. As you can see, like on the slides, we provide like a lot of services. We do a lot of cool things. I don't want to dwell too deep into that, but rather go into the topic itself, namely blockchain in manufacturing. I mean, as Teresa said, blockchain often associated with cryptocurrencies and new financial products, new financial services. And that's not incorrect, but I want to like take a step back and like reflect on what blockchain actually is and how it then can help in non-financial use cases.
Mm-hmm. Vinzenz, one last remark before you dive really deep into the topic. He's going to mention it later as well, but for everybody that's very interested in the topic, there's going to be some trainings available, but we are going to talk about that in the Q&A session. And the last remark before I fully give the floor to you, Vinzenz is very happy to answer any questions after his presentation. So in case you have questions, please put them in the Q&A tool, which you can find at the bottom of your screen, or you can also use the chat to send us your questions. We will take some time after the presentation to answer them in detail. And if there's a question that you find very hard to put in writing, just please virtually raise your hand and we're going to bring you on stage so you can talk to Vinzenz directly. And with that said, Vinzenz, now the floor is yours. Have fun.
Thank you. So, I mean, if we take a step back and think about what blockchain actually is, I have a very simple answer for you. Blockchains are databases. So blockchain technology is a database technology. And within this big field of databases, you have something like distributed ledgers, which are databases that which are spread over over a computer network. And then you got blockchain databases as a subset, which are also spread over a computer network, but the nodes of the network are operated by independent parties. Now, as a database technology, blockchain combines a lot of interesting concepts And while they are databases and use a lot of general database stuff, they also combine that with a lot of cryptography and with peer-to-peer network concepts and game theoretic concepts. So blockchain as such, or the innovative aspect of blockchain technology, is not single technologies that are used to comprise this technology, but rather the smart combination, so that you use like database technology, use cryptography, use game theory, and you use like a peer-to-peer network approach, and you combine that all and get a pretty interesting database technology. As some of you might know, the concept itself was first introduced by a white paper by a person or group of persons known under the name Nakamoto. And it was introduced to serve as the infrastructure for a payment system, namely Bitcoin. The open source implementation was available in 2009. So the technology itself, it's, I mean, the foundations of the technologies go back into the 50s or 60s. And the actual combination of these technologies into something we now call blockchain is also more than 10 years ago. And of course, the technology developed. Now, blockchain, if we think about the term, of course, like where does it come from? As I said, it's a database technology and with a few special features. And one of those special features is the data structure it uses. Blockchain stores data in blocks, and it connects these blocks to one another. So as you can see here in the diagram, you start with a block which contains some metadata and then your actual transaction data. And what you do is you hash the whole block, and this serves as an input for the next block, which contains additional transactions. And you do that for block 3 and block 4 too. Now, a hash value is a hash function is a cryptographic function. That's where the cryptography comes in. And basically, it's a fingerprint of a certain data set. And chaining these data entries via these hash values leads to some interesting properties. Because if you change something here in block 4, for example, some transaction data, due to this interlinking by hash values, it becomes immediately obvious that the data has been tampered with, for example. Also, if you put the data into blocks, you get a nice chronological order, which can't be changed after the fact. So all are characteristics that are pretty good for if you want to prove some certain data states. A second interesting thing about how blockchain works is how you get a consistent view of the database. You remember I said distributed ledgers are distributed databases, and blockchains are distributed ledgers where the nodes themselves don't necessarily trust each other. So basically what you need there, if you have a lot of independent parties running a database together, you make sure that everybody has the same data. This is done by a lot of communication. So a lot of messages get sent around between those independent nodes, and the node operator here serves various functions. I mean, you manage a local copy, that's clear. You check validity of transactions coming in. But here it becomes, in the fourth bullet point, becomes interesting because you can participate as an independent operator in the processes and mechanisms to keep the database consistent across the whole network. This is sometimes called mining with older protocols, or validation with newer protocols. So much for like the core technology. People, the participants here today who know a little bit about the topic this slide will seem very familiar because it describes the mechanisms behind Bitcoin. However, it's very important when we talk about blockchains that you keep a second thing in mind, besides that it's a database technology. And the second thing is that it's a technology family. So a lot of you will have heard about the Bitcoin protocol or Bitcoin in general. And that's the first instance of blockchain technology, but it is not blockchain. Blockchain is a family of protocols that like Ethereum, like Solana, IOTA, Algorand, and all these protocols, they might share some common characteristics, like they're all decentralized databases, they all have a network layer, they all use cryptographic functions and processes quite heavily. But all these different protocols have significant differences in terms of accessibility, in terms on how the actual mechanism works, that you have a consistent view on the data across the network, also what technical features they support, and also like how they are managed, organized, and run on a community level. This is a good thing because in the past 10 to 14 years, while we were working on blockchain, it became apparent quite quickly that certain types of protocols or certain protocols are better equipped to handle some use cases than others. While Bitcoin, for example, is very apt at supporting the original use case of having a network for value exchange, in other cases or use cases, it's not so appropriate because, for example, it uses a lot of energy. Which brings me to my next point in the intro. And this slide I have now in all of my presentations, because the question always comes, isn't blockchain a very inefficient technology or guzzles a lot of energy? And yes, but it depends would be my answer to that one. Because as I said before, blockchain is a technology family, which means that you have a lot of different instances of or protocols of this family. And one of the characteristics that they differ from each other is the actual energy use. And here the key characteristics is mainly the mechanism for keeping the database consistent. So it's also called the consensus mechanism, where you have various implementations such as proof of work or proof of stake. And then, of course, you have additional factors like the size of the network general activity. And especially in industrial applications where you often have to operate in a low energy environment, that energy consumption of the blockchain node can become a deal breaker. However, as you can see from the table here, different protocols differ in terms of how much energy they consume as the network as a whole, which you see in the first column, and how much energy you need to actually effect one transaction. And while it's true that Bitcoin uses a lot of energy because it's a blockchain based on proof of work, Other blockchain solutions use tremendously less energy. And on a transaction basis, sometimes they can go down to as low as the amount of energy you need to send an email. So having talked a lot about databases and a little bit of the underlying mechanisms there, maybe let's take a step back and talk about or take a more big picture perspective. Now, so blockchain is a database technology. It has some special features, and these features bring certain advantages, like decentralization, like a consistent joint data layer, like finely granular transparency and traceability, which would enable audits. You have an immutable database through the use of cryptographic functions like hash functions. You have a distributed database that offers you benefits in the terms of redundancy. And last but not least, you have a lot of flexibility with a lot in as such that you can make a lot of applications actually happen. And these characteristics of blockchain technology have turned out to be especially beneficial in situations where you have like several independent actors that need to work together, but do not necessarily can trust each other. So in any situation where you have these several actors who don't trust each other, blockchain might be a solution that is beneficial. As the digitalization that we see now, I mean, it comes and goes in waves. But what we've seen in the past years with regards to digitalization, there was a lot of intra-company digitalization. So business processes within a company got digitized, supported by new tools. Currently, we see more and more inter-company business processes being digitalized. And there you're exactly in the situation where you have suddenly several independent actors, and they can't trust each other. So blockchain might be a solution here. I mean, another, and if we look a little bit deeper, and I brought here the Gartner hype cycle for blockchain to today, is that blockchain is discussed for a lot of applications, also with regards to industrial or manufacturing applications since years. And you might notice that this is a rather old chart, 2019, so like almost 5 years old. And what we've seen here when we observe the market is that a lot of things that were discussed as possibilities 4 or 5 years ago, we made a lot of progress, and we are more nearer a production-ready environment with some of these technologies. And combine that with the fact that the most of the points here are seen on a 2 to 10 year time horizon. It's definitely that the time of blockchain seems to have finally come for the manufacturing sector too. The second chart I brought you is the manufacturing digital transformation hype cycle, also from Gartner, where blockchain has also finally made it onto the chart, which is here in the earlier stages with long time horizon. However, if you take a closer look at the technologies and concepts discussed in this hype cycle, you find something like digital twins, industrial IoT, or 3D printing of industrial parts, which are very interesting use cases where blockchain can add tremendous value if implemented. So from a big picture perspective, blockchain as a technology is very interesting for the manufacturing space. And as I said, what we see now is as a lot of processes become more and more intertwined between companies, you have these beneficial constellations where distributed database can really add benefits. And the fields of applications that are made possible by blockchain are numerous. I mean, starting with documentation, data exchange, something like certificates of authenticity, traceability of production processes cross-company, but also like additional or like higher level use cases like usage-dependent billing models or insurance premiums become possible with blockchain technology. Of course, I'm from the ABC, the Austrian Blockchain Center, and so I see a lot of applications for blockchain. However, what you have to say, the rule number one when thinking about blockchain is that in most cases, there is no need for blockchain. Because if what we hear quite a bit is people approaching us, let's do this or that with blockchain. A closer analysis shows that the constellation where blockchain actually can play out its advantages are fewer than initially thought. And in some cases, it simply doesn't make sense to use blockchain. So after this general introduction to blockchain, let's maybe look at one or two use cases that we see in industry and more generally manufacturing. I mean, one use case where blockchain can add tremendous benefits is in supply chain management, because there you do have this situation that you have a lot of independent actors that need to collaborate, but cannot trust each other. And yes, it would be possible to introduce a central platform for supply chain management, but that doesn't work out in most cases, because a lot of actors in the space are actually direct competitors. Second, blockchain introducing a unified data layer can add a lot of benefits, because it can make the complex processes behind supply chains more transparent, and therefore it can help in conflict resolution. So of course, like there are a lot of different implementations of blockchain in this space of supply chain management. And there, I want to reference back to what I said earlier, that blockchain is a technology family, and there are very open blockchain systems, so-called public permissionless blockchains. But of course, there are also other blockchains which have much tighter accessibility. And you could, for example, configure access rights on a very fine granular level, so that participants in such a system or supply chain that is supported by a blockchain do not have to give away information that is competitively sensitive. In a supply chain setting, I mean, what are the use cases that we concretely see? I mean, everything that support or connected to tracking and tracing and the documentation of process steps is something where blockchain can add value due to its characteristics of being an immutable database. And based on this information, you can create use cases for example, certificates of origins or quality certificates in order to protect against fraud. Another area where there's a lot of interest and where blockchain can add some value is in the field of sustainability. And that starts with CO2 certification, but also goes into areas like the supply chain responsibility reports or requirements. You might have heard, but there's something like, especially in Europe, discussed the supply chain responsibility directive, where manufacturers or original equipment manufacturers are actually made liable or responsible that in their upstream supply chain, certain sustainability criteria have to be fulfilled. So if you create a unified data layer where everybody reports and you can cheat on the data, that makes your life as an OEM tremendously easier. But of course, blockchain also enables more completely new business models. And the second example I brought you here is Lindner Traktoren. So these are manufacturer of tractors. They also lease tractors. And the use case here is that the tractors are very good, but the business model behind leasing the tractors was still like old school 20th century, because it was purely based on time. And if you come from manufacturing, or if you have a manufacturing background, time is, it's not so important. It's rather usage that makes or breaks the machine. So what Lindner did in a pilot is they recorded usage data from sensors within the machine and recorded it on the blockchain and made that the basis for their building model. Because obviously, if the tractor is transported on a truck to a farm, it's not used, so there's no wear and tear. Also, if the tractor stands there at the farm, no wear and tear. And then if the tractor drives to a field, there is some usage, but it's light duty usage. So that can be built differently from actually plowing a field where you actually have the wear and tear that breaks the machine in the long term. So recording that automatically via IoT sensors and storing it in an immutable database that every participant stakeholder can trust, enable them to have better billing models for their machines. And if you think a step further, of course, once you have the data in the machine, you can also have something like smart contracts, so automated computer programs residing on the blockchain to process this data. How could you process that data? For example, you could automatically trigger the payments of the leasing contract via the data generated by the machine. And this works with especially good in a blockchain-based environment because the data layer as such can't be tampered with. So the manufacturer of the machine can be sure that the user or the machine reports the correct hours. And also if a bank, for example, gets a payment instruction from the blockchain system, it can also be sure that it hasn't been tampered with. And you can like spin that further and further, for example, that you have like usage-based insurance premiums, or for predictive maintenance, or even like go a step further, but like financing by the bank, that your like loan lines or credit lines are based on the usage that your machinery delivers. Another example here from the steel industry is mill test certificates. This is also it enables, just in short, because I have to look at the time a little bit already. Basically you have like an ingot of steel gets equipped with this like little hardware device, and on this hardware device you can basically store the data that comes along with this device. I mean, currently there's a lot of paper or PDF-based documentation with these raw materials, and forgery is a problem. If you store that on this device, which is attached to the physical product, and then anchor the fingerprints of this data on a public blockchain system, you can create an auditable paper trail, which comes in pretty handy if you have to, for example, prove the origin of your raw materials, for example, to a regulator. Yeah, that was like a brief introduction into what blockchain is and a few use cases that we see in the industrial space. And I mean, as Teresa said, we also offer courses in this field where people get the chance to gain a solid knowledge of the technology and its applications. As ABC, it's important for us that we cover blockchain not only from a technical perspective, because a lot of people do that, but also from a business and legal perspective, which is actually crucial if you want to implement something. And yeah, maybe some background on the courses. We offer them at 3 levels: basic, intermediate, and advanced. Basic course covers like the basics. I see Noor put in some links in the chat here, so I'm not going to talk too much about it. Maybe a bit of information. As I said, I come more from a business side, or approach the blockchain technology from a business side. But in the course, I work together with Stefan, who is the area manager technology at ABC, and he will cover more the technical aspects of blockchain technology. Here, a nice picture of me. Teresa, will we be distributing the slides? Okay, so you have my contact details in the slides. And with that, I open the floor to questions.
Thank you so much, Vinzenz. That was really interesting. And we're actually having the questions coming in.
Okay.
But before we go to those, I have one question, and this is you mentioned many use cases and requirements and application fields. So if we think about now blockchain technology in the industrial setting, like really shop floor, where do you see the biggest challenges there to introduce this technology?
Well, from a more technical perspective, the biggest challenge is to use the appropriate blockchain technology, because most of the time the full potential can be reached if you combine it with IoT approaches. And then we're talking about sensors with not a lot of computing power available and not a lot of energy or electricity available. And to craft the technology so that it can be executed, or that a sensor can, for example, self-report data, that's a practical challenge we see when we talk about the shop floor.
Okay, so many companies are just not ready from a equipment perspective.
Well, I mean, it depends. Like, of course, it helps if you already like have modern equipment. But I mean, blockchain here, once again, from a bigger picture perspective, it's one part of a larger digitalization effort, I think. And of course, stuff like IoT capabilities are also a big trend here. And of course, stuff like AI support are also a big trend here.
Okay, thank you. So we have in the Q&A tool a question from an anonymous participant. And Vinzenz, I'm quite curious now if you can answer that, because it relates to the Gaia X project Catena X. So the question is, why is Catena X not using blockchain technology if it is actually a fitting use case? So I'm not sure how deep are you in the Gaia X topic and know about the Lighthouse projects.
I have to admit I'm not so deep into that. What I can share from you from experience with other projects is, and we've seen that since, well, let's say 2017, there was a steady development that projects hit their use of blockchain technology. So when crypto prices are high, everybody blurts out, "Oh, we're doing blockchain." When the prices go down, projects say, "Yeah, we do that, and we also use blockchain." But with regard to the specific question, I haven't looked deep enough into it to give you a definite answer there.
Okay, so whoever posted that question, maybe you can reach out to Catena X directly, or we also have some experts for another Gaia X Lighthouse project, which is Euprovigant for industry. So if you want to talk about that in a little more detail, just please reach out to us afterwards. We got another one, but I'm just gonna focus now on the questions from Ronan that came in the chat. And he said, Vinzenz, you mentioned the potential for blockchain over the next 10 years, but you also said there's often no requirement for the blockchain usage in many use cases.
Yeah.
So his question is, what is the best way to evaluate this? Because he has a keen interest in blockchain use in the fine wine buying industry and seems to be a natural fit, but he's curious how to prove that. You know, when is it appropriate to use blockchain technology?
As a general rule of thumb, it's, as I said, it's constellations where you have several participants or actors who have to collaborate and who cannot trust each other. And if you have a situation like that, plus you don't have a trusted third party, which you can task with doing the stuff for you, then you might have a very good use case. as an example, in Austria, like a land register or land ownership rights would be a good use case for blockchain, because I mean, you have a high value piece of property and you cannot actually trust other people. However, in Austria, we have a very good centralized solution. So the land registry use case with blockchain, although a lot of people came to us with it, is actually a no-go in Austria. But evaluating, to come directly back to the question, evaluating whether or not it makes sense is often the first step in any blockchain-based project. And in my experience, in 75% of the cases don't use blockchain, just from the initial project flow. In the fine wine business, there are several examples that are where blockchain is a good fit.
Mm-hmm. Ronan, please let us know if that answers your question. He sent another remark that it refers to investing in fine wine and transparency. Mm-hmm. So let us know, please write us another message if the answer is suitable, or if you have some more things you'd like to discuss.
Maybe just to if I understand Rowan correctly, this would involve fine wine trading. So probably a lot of you don't know, but there's a market for fine wines where you can actually invest in fine wines. And this becomes more like as an investment vehicle. And then naturally the answer or the question would be, can I trade my wine? And here blockchain would offer the possibility to digitalize, create a certificate of ownership for a specific bottle. And this certificate then can be much more easily traded than the bottle itself. What you would do there is store the bottle with a custodian who ideally stores it, right temperature, right moisture, and so forth. But the ownership certificate is represented on the blockchain. Okay.
Thank you very much. We have two more questions that refer to the use case Lindner that you presented. So the first question is, in the Lindner case, how many blockchain nodes are used and who owns those nodes?
In the Lindner case, the pilot I studied, there weren't so many nodes because it was a private permission, if I remember correctly. So you had a pretty small network, and as far as I know, I haven't been directly involved in this project. That was due to privacy concerns, because obviously, machine usage hours can be, let's put it that way, a trade secret in a sense.
Okay. Maybe you have information on the second question that one of our participants put in the Q&A tool. Which type of blockchain database or technology supplier is used for the manufacturing use cases like at Lindner?
It actually depends on the concrete use case, what makes sense. What we work with is normally a combination of technologies. So you have something like private permission blockchains for the unified data layer, where you actually can store information with hashed data state values stored in a public system, for example, like Ethereum for added security and tamper-proofness. But in the end, it depends on the concrete use case, and that depends on a lot of things. I mean, in the manufacturing sector, it's not so often that you collide with GDPR, which is a problem if you have the right to be forgotten is a problem if you have an immutable database, but it more goes into trade secrets. So, for example, you could store the exact manufacturing process of, let's say, a steel alloy on a public database. But for competitive reasons, you might not want to do that. Even if it's like hashed, you have to be, in some cases, you have to be careful there.
Okay.
So it's normally a mix of technologies and dependent on the concrete use case and its requirements.
Okay, makes clear sense. Then I see one more question. Do you have any information about digital product passports in manufacturing and blockchain technology, Vinzenz?
Yes, I mean, this actually is one of the biggest topics discussed right now, that you securely store such passports on a blockchain, because and along a value chain, so that like pre-products get stored there too, which can then feed into assembled products, and the blockchain in these type of applications normally is used to prove that the product passport hasn't been tampered with. And it can, to some extent, also be used as a certificate of ownership. So if we come back to the fine wine, that it's not possible to sell the physical bottle with also providing the digital twin of the bottle. Because the market do's and don'ts say like you can only buy them both together or not at all.
Okay, thank you. So if there's more questions, please don't hesitate to ask them. In the meantime, I have one more question for you. You mentioned earlier, and also my colleague put it already in the chat, that there will be training programs available on blockchain in manufacturing. And there's 3 different courses. So it's a basic, an intermediate, and an advanced training. Maybe you can let us know what will be the content of each training and who can profit from each of those courses.
Let me maybe go back 2 slides. So basic, intermediate, advanced, and who can profit. I mean, in the basic course, we cover the technology basis, some use cases in the manufacturing and industrial sector, and trends we see. So it's a lot like today, maybe, but more extended, more hours. Probably people who just heard or read in the general media about blockchain, but don't really, know their way around. They can profit most from that. The intermediate course requires some pre-existing knowledge about the basics of the technology. So you have to need to know like how a blockchain works. And then we can talk about advanced technologies. We can talk about protocols and their differences, the ecosystems that are required around them. And we can also dive deeper into like how to actually evaluate use cases and some legal perspectives. However, that requires that you know your blockchain basics, because we can't explain to you how like a proof of work consensus mechanism works or a proof of stake consensus mechanism. So we go more to the higher level concepts.
Mm-hmm.
And last but not least, the advanced course. Here we flip the approach and we say like we guide people through thinking about implementing blockchain. So the advanced course is more based on the principle, like we develop a use case, an idea, and then we, within the bounds of the course, we try to, like, you know, conceptualize it. So think about, like, okay, which tech for my concrete use case, how does it look like? What technology do I use? What requirements do I have to fulfill? How would an architecture for this use case look like? And that's definitely, here you have to be familiar with blockchain technology in order to actually profit from this course.
Okay, and is the basic required for the intermediate and the intermediate required for the advanced, or can just anybody with some pre-existing knowledge join any course?
Yeah, I think like what we do require is that you do the intermediate course before you join the advanced course. If you have working knowledge on blockchain technology, we do not make you do the basic course before you join the intermediate.
Okay.
Yeah.
Very good to know. Thank you. So everybody, you can see the dates of the upcoming courses on the slide right here. Just to make you aware, there's an early bird discount available still for the courses. If anybody's interested, please just use the links that my colleague pasted in the chat. And if you have any questions, you can always contact us and the following email address.
Mm-hmm.
And I don't see any more open questions. So here's the last chance to ask your question. If not,
and I mean, if you have any questions, like in it, you know, you leave the Zoom call and then I wanted to ask this question, just write me an email or write Teresa an email and she will forward it, and I'm more than happy to reply.
Absolutely, thank you. That's great. So we're gonna make the recording and the slides available. You're going to get an email with the links to the recording as well as the slides, where also Vincent's contact information is up there. So if you have any open questions, if you need any more information or would like to join one of the courses, but you need some more background, just please feel free to reach out to us. We're always happy here to help you out and happy to answer anything and any questions that you might have. With that said, I don't see any more questions. So I think we going to end this webinar, wishing everybody a great rest of the day and a great rest of the week. Here in Vienna, it's a little rainy, so I hope the weather is nicer from wherever you are joining. Thank you, Vinzenz, very much for all your insights and your availability. And yeah, goodbye. Have a good afternoon.
Have a good one.
Bye-bye.